Olsson is professor of geography at Lund University and the founder of the Lund University Center for Sustainability Studies, for which he was the director until August 2016. He's also the principal investigator and coordinator of the Linnaeus Center. His research fields include human-nature interactions in the context of land degradation, climate change, and food security and sovereignty in Africa and globally. His current research focuses on the politics of climate change in the context of poverty, food insecurity, and ill health in sub-Saharan Africa and beyond. He has had research positions in Australia, the US, and Hong Kong, and participated in several international assignments, including the IPPC and UNEP GEO assessments. He was coordinating lead author for the chapter on livelihoods and poverty. If you're looking for it, it's chapter 13 in the IPCC's fifth assessment report, 2011 to 2014. Most recently, he was the lead author of a chapter on land degradation in the IPCC special report on climate change and land, which Tim Cruz was also a contributing author. He is our collaborator. He is a board member of the Land Institute, and I am super excited to introduce to you Dr. Lennart Olsson.
Thank you, Rachel. You just made a big mistake. Yeah, because you know there is a very simple recipe for success: to lower the expectations. And so all these nice words was a big mistake. And yeah, I will. There was one thing that made it very easy to jump in with short notice, and that was that Carolyn's title was "To be decided." But that's the only easy part of jumping into a program like this, and especially to come after such an elegant speaker as we had before. So the title, pardon? Okay, I will. The title of my talk is, I want to give you a little bit of an international flavor. So it's from Copenhagen to Salina via Paris. I could have given the title A Political History of Climate Change, but I didn't want you to fall asleep already, so I choose the other one. I would like to start in Copenhagen, 10 years ago. That was a place where the people also misunderstood who you make success, because they had raised the expectations to an incredible level. In Copenhagen, the COP15. They had raised the expectations so high that 50,000 people came to Copenhagen, where they had a venue with the capacity for 30,000 people. They had even coined the term, "Come to Copenhagen." And of course, the conference with such expectations could be nothing but a failure. So afterwards, most people said, Copenhagen. And it was really a very, very severe backlash to the entire climate politics, because we thought that we had come to a stage where the science was really strong, uncontested, and that we would now see a major political breakthrough. That didn't happen. And there are several reasons to it. I won't go into the details. But I think there was one important thing, at least, that was decided and accepted at the Copenhagen meeting. And that was that governments in the world accepted a target, the 2 degrees target, saying that we should stabilize the climate at a warming not greater than 2 degrees compared to pre-industrial level. In order to understand this 2 degrees target, it's a really, really important thing here. We have to make a little detour to Rio de Janeiro in 1992, the birth of the climate, the UN Framework Convention on Climate Change. Because it was called a framework convention, not a convention. So why? All the other conventions, there's a convention on biodiversity, there's a convention on desertification. Why a framework convention on climate change? Because it was empty. Completely empty, because governments couldn't agree on anything. They were able to agree on one thing. So you can actually take the entire 200 pages of bureaucratic gobbledygook and just summarize the UN Framework Convention in one sentence where there's one word that is important. And that sentence says that the objective of the Framework Convention is to stabilize the climate at a level that will prevent dangerous interference with the climate system. And this word was key, dangerous. And of course, it was easy for governments to agree on something that is, we should prevent something dangerous, because we don't want anything dangerous. But of course, what is dangerous is very different depending on who you are, where you live. So what was dangerous to the small island states, for example, like the Maldives or Tuvalu, that was that they were going to disappear. Or what was dangerous with climate change for Bangladesh is that 30% of the country will be underwater. And what was dangerous in climate change for Saudi Arabia is that they would go bankrupt. And I suppose what is dangerous to Donald Trump is that he will lose the election. So what is dangerous is very, very contextual. So all the years between 1992 and 2009, the political establishment struggled. How can we get some more substance into it and just get away from this dangerous? And at Copenhagen, they actually managed to reach the 2 degrees target. Many people were happy. Some people were not happy. One of them was Jim Hansen, the very, very well-known and respected scientist at NASA. He said is deeply irresponsible. It is a recipe for global disaster to have a 2 degrees target. He said we have to stabilize it lower. Many countries, especially in the global south, they were furious because we are already losing our land, our assets are being eroded, and we are just something like 0.7, 0.8 degrees warming. So therefore, there was this sense of we had some kind of progress with the 2 degrees, but many people were deeply upset about it. So then let's move to Paris in 2015. It was a very different conference. First of all, they had a much bigger venue, so they could actually allow everybody in. And the French, they have many characteristics. But of course, they invented diplomacy, and they showed how good diplomacy can actually deliver a result. So the Paris conference was a beautiful show of diplomacy at its best. I suppose you have seen the pictures from the final plenary meeting of the Paris Agreement. Everybody is standing up like this, because they had reached an agreement where all countries endorsed the 2 degrees, and they said something, and we will try, make every effort to go down to 1.5 degrees warming. So the question is, how come that at the Paris Agreement they actually reinforced this and said we can actually, we want to do it to 1.5? There are rumors, unsubstantiated by well-informed rumors, that it was an agreement between North America and Europe and the group of developing countries that, because many people asked, how could Europe and North America agree to this? And that was that the developing countries promised, if we can have the 1.5 degrees in there, we will not ask for loss and damages, compensation, economic compensations for the damages. Because that had been a very, very big controversy before, that the developing countries were actually asking for very legitimate claims, asking for compensation if there is damage due to climate change. So, so the Paris Agreement was a great success, but scientists asked, what have they, do they know, do they understand, the politicians, what they have agreed to? Is it possible to establish or to reach a 1.5 degree? So that's where IPCC comes in, because IPCC was then commissioned to write a special report on 1.5 degrees global warming. There were two important reasons for that, because it was a landmark report, and Fred talked about it earlier. One was that many of the small countries, they were deeply unhappy with what has been done before. So they demanded a report looking into what are the differences between a world with 2 degrees warming and a world with 1.5 degrees warming. And there was another reason, and that was because of Saudi Arabia. They were very, very much against all this talk about 1.5 degrees. And Saudi Arabia are absolutely super-duper negotiators. They're extremely skilled. I would like many other countries to be as prepared and skilled as Saudi Arabia in international negotiations, but of course with another end result in mind. So because the Saudi Arabia said very, very clearly and correctly at the Paris meeting, there is no scientific support that it is possible to reach 1.5, and that 1.5 would be different from 2 degrees. And they were right, because scientists didn't think that would even be possible. So Saudi Arabia thought, if we can agree that IPCC will do this report, they will probably never be able to show that 1.5 degrees is significantly different from 2 degrees. So the scientists in IPCC was given this almost impossible task to review and assess science that wasn't there. What is the difference between 1.5 degrees and 2 degrees? But they did a fantastic job. And a year ago, it was presented. And I'm in the business of reducing paper. So if we reduce the UN Convention to one sentence, I would like to reduce the 2,000 pages of the 1.5 degree report to 3 bullets. The first bullet is, every 10th of a degree matters. So in essence, it's really, really worth all the effort to trying to reach 1.5 instead of 2. Every 10th of a degree matters. That was a very strong message. We can actually illustrate this difference with pretty horrible figures. If we manage to stabilize at 1.5 degrees, we will only lose about 80% of the coral reefs in the world. If we go to 2 degrees, there might be 5% of the coral reefs left for future generations. The second bullet was, it is still possible, because many scientists had said before that we have already committed ourselves, with all the emissions, we have already committed ourselves to more warming than 1.5 degrees. So it was a very strong statement that it is biophysically still possible. But time is running out very, very quickly. So in a sense, you can say that every year matters. And then the third bullet point was that cutting the fossil fuel emissions is not enough. So even if we stop emitting carbon dioxide and other greenhouse gases from coal, from oil, from natural gas, it's not sufficient. We need to do many other things as well. So every sector matters. And this is where the land sector comes in. And this is where the next IPPC report comes in. And we're coming close to Salina now. So bear with me. The second report that was released last month, the IPPC special report on climate change and land, was a kind of reality check of that 1.5 degree report. Because the 1.5 degree report had mainly been written by scientists that come out of the modeling community. They are integrated modelers, they are computer scientists and very skilled with juggling data. But most of them had no clue what the land really is. All the sort of the real world constraints from biophysics and land use and culture that is based on land. So the 1.5 degree report said that there are 4 pathways that we can reach 1.5 degrees. 2 of them were deeply problematic, but they were very much liked by some organizations and some businesses, because they showed that it isn't that urgent to slash the fossil emissions, because we can reorganize land to suck up enormous amounts of carbon using a technology which is called BECCS, the bioenergy combined with carbon capture and storage. It is a useful technology, but I think it is the scale that really matters. So in essence, they had 2 scenarios. And in one of the scenarios, they said, if we have twice the size of India as dedicated biomass production, that we will then burn in power plants to generate electricity, separate out the carbon dioxide and put it somewhere. And the other scenario was having the size of 1 India for dedicated biomass production. And to a geographer, where do you find all these land where you can have sort of the size of 2 Indias for dedicated biomass production? Most land is owned and used by somebody. But this was really picked up by the fossil fuel industry. And the fossil fuels industry was actually quite pleased with the whole thing. And I don't know, some of you might have followed Shell, what their plans are. Because they have a scenario, they call it the Sky scenario, where they promise to solve climate change for us. So we don't need to worry. We can just go on, because they will solve it for us. And the tactic is to be very, very quiet about the first couple of decades. And then giving very, very rosy promises, what can be done in 2060, 70, 80, and 90, and so forth. And it's actually based upon a brilliant business idea. Because it's based upon the idea that first you burn all the known resources of oil and gas you have. So you earn money on releasing carbon to the atmosphere. And then you just switch and you start to earn money on taking all that carbon back again. So I hope that the latest report, not the latest because that was on oceans last week, but the one in last month, Climate Change and Land, will, I'm not naive enough to think that it will stop Shell's plans of doing this, but I hope that it will raise the awareness that we need to be careful what we do with our land. So you can say that if we should organize the land resources based upon ecological principles and principles of social justice. If we do so, the land sector will make a sizable contribution to solve the climate problem as well. But it's not sort of a shortcut to and it's not a way to allow continued emission of fossil fuel. But if we organize the land area just based upon maximizing the climate benefit, I think that is a recipe for disaster for the planet. But the very strong forces trying to see the land as simply a carbon sink. Now we're coming close to Salina. I think it would be pretentious of me to say that Salina and the Land Institute has the solution. It's pretentious even to say that the Land Institute has a solution. But the Land Institute has a seed to a solution. And this is extremely important. So this is one of the most, being a scientist, I spend most of my time trying to criticize things, trying to find holes. I mean, that's what we scientists do. And I've tried hard to find the holes in the natural systems agriculture approach. Where are the sort of the loopholes? What are the weak points? I'm sad to say I haven't found many. So I really think this is an extraordinary seed to a solution. But as you know, seeds, they require soil, they require nutrients and water. And what we have here, I think, is a small piece of very fertile soil. It's a little bit of a drought, perhaps. And for this seed to really have an impact worldwide, I think we need to create much more soil in the world. And then find the nutrients and find the water. So the Land Institute is now being sort of a new member of the board. I'm so pleased to see that the next step of the Land Institute is that we're now planning to organize some kind of or create an international organization, because there are now so many research groups around the world contributing to this research. And it's still a very, very informal network of some 40 plus research organizations around the world. Most of them are small. They are driven primarily by compassion rather than funds. And this is not going to change the world quickly enough. So therefore, I think the next step is to create this international organization is extremely important. Creating more soil, more patches of soil in the world. Then we need the nutrients. Luckily, there is lots of nutrients around. Nutrients in this case is brilliant minds and people who are skilled and compassionate about developing this. We had a meeting at Lund University, which I organized together with Tim in May. And I think that to some extent we made the same mistake as Copenhagen. We organized such a grand meeting, but with a capacity for 60 people. 95 came. But we were able to host them all. So we can see, I think there is a tremendous interest out there. And there are many, many people who would like to contribute, just if we can provide the opportunities for them. And luckily, the Land Institute is still a brilliant intellectual hub, recognized by all these partners around the world. And then, of course, we need the rain. And we're working on that. I know that many people here have probably contributed to some of that rain, which we are very grateful for. But there is one warning I see. There is a dark cloud on the sky, and I learned that from being part of the climate change research community for so long, and especially working for the last 10 years within IPPC. In IPPC, we thought we had won the struggle against the climate contrarians in 2007. It was a great year. We were releasing the 4th assessment report. The science was stronger than ever. We even shared the Nobel Peace Prize with Al Gore that year. And hell broke out. There was an organization specializing on finding finding dirt on climate science. They broke into one of the email servers of the Climatic Research Unit, University East Anglia. They looked through our reports. And unfortunately, what they did, in the 4,500 pages of Assessment Report 4, they found 4 factual errors. 1 error per 1,000 pages. But they were blown out, completely out of proportion. The most severe error was that the scientists say that the glaciers of the Himalayas will disappear in 25 years. And that was incorrect. It would probably take 50 years. The other error was that the scientists say that 50% of the Netherlands is below sea level. That was also incorrect. It's 39%. But the figure came from the Netherlands Environment Protection Agency, so I think the scientists were excused. So the IPPC had to go through 8 independent, very tough reviews. One by the American National Academy of Sciences. And it came out absolutely clean after 8 independent reviews around the world. But the damage was done. So the lesson from this is, when the scientists think, yes, now we have a strong science, we have won the struggle, that's when the problem starts. Because weak science is not a threat to anybody. A weak science is, you can ignore it. But when the science becomes strong, then it starts to challenge important, powerful interests. And they often have very ruthless ways of pursuing what they do. So I think in the same vein, I think it's an absolutely fantastic progress for the Land Institute that we now have the evidence that it is possible to domesticate a wild perennial plant and turn it into a domesticated cereal. It is possible. And the same with rice. Great successes. But maybe this is the point when we will be contested much more than before. We have been allowed sort of to develop and do our stuff because people didn't think we would actually be threatening anything. So this is my little warning to the Land Institute. Be prepared. Okay, so we are in Salina, and I think we are part of this very important seed. And I would like to end with a tale from the future. So when my great-grandkids, or when Greta Thunberg's grandchildren, when they go to school, they will read in the history books about something that happened in the 20s and 30s. And in the history books, it's called the Perennial Revolution. And the Perennial Revolution was a very short time in history when there was a very important change in the science, so that people started to abandon the old practice they had done it for 10,000 years of using annual grasses to eat. And that changed so much of the world. It contributed to avert a major climate disaster. It contributed to the fact that we are now, 2070, on our way to a stabilization at 1.5 degrees. It contributed to preventing a further expansion of the dead zones in the oceans. It actually brought down the agrochemical industrial complex. So that's my hope, that is what will be, yeah. And also the kids, they will be amazed. They say, how could they be so stupid? For 10,000 years, they were eating annual grasses, when it was so simple to just switch to the perennials. So that's my vision and the end of my story. Thank you.
Thank you, Lennart. We do have time for some dialogue. I saw this hand first. It is not necessarily first. I just saw it first. Can you pass it?
Yes, Lennart, thank you very much. In reading Drawdown, with many approaches to drawing down the carbon in the air, there's carbon in the air that's heating up the planet, carbon in the oceans, carbon in the plants, carbon in the ground. Which absorbs the most? Somewhere I have read that there is 5 times the carbon sinkability in the soil compared to all the plant life on Earth. And with the agro-industrial complex having destroyed the soil with chemicals, fertilizers, rendered it dead and everything, is that true? Would you agree that we can improve that soil and get back on track? Thank you.
Thank you. Great question. I wouldn't say that there is a 5 times bigger sink below ground, but in general, we say that there is something like 4 to 5 times more carbon below ground than above ground. Even in one of these impressive large forests with tons of biomass growing for hundreds of years, there's still 3 to 5 times more carbon in that soil. When we first transformed natural ecosystems to agricultural systems, we lost much of that soil carbon. I mean, we definitely lost much of the above carbon, of course, because the trees store a lot of carbon, but also much of the soil carbon. So it depends on where you are in the world, what kind of soils, but something between 30 and 60% of the soil carbon was lost, sometimes up to 70%. And of course, the more carbon you've lost in a soil, the bigger is the potential to put something down there. So the more degraded a place is, the bigger is the potential to store carbon in it.
May I follow up on that? Dr. Law did a study to figure out how the carbon had come in the last 150 years. And his conclusion, looking at the carbon that had been in the soils and what was there now, and I think he only looked at topsoil, which would have not really counted deep perennial roots as well as it could. He said that roughly a third of the carbon gain came from fossil fuel burning, and 2/3 came from liberating soil carbon. That was carbon only. If you add global warming impact, it's a little greater from the soil because of methane and others. I don't hear anybody talk about that. Everybody seems to think it's mainly a problem of having burned the fossil. May you comment?
That's a bit of a controversial. I suppose you refer to Ratan Lal, the soil biochemist, that he claims that a majority of the carbon we have now in the atmosphere has come from depleting soil carbon rather than fossil fuel. Pardon? 2 to 1. Yeah, 2 to 1. The exact amount is actually it's really questioned. And I would probably like to ask Tim, what do you say about this? But I would say, it is, I don't know if Ratan Lal has said this, but I think it's incorrect at least. I mean, it also depends on over what time periods. I mean, the thing with carbon dioxide is that the residence time is about 100 years on average. And we started to release soil carbon 10,000 years ago. But of course, much of that has disappeared already. But it's definitely a significant amount of the climate change that comes from overexploiting soils.
Can I go ahead next? Is that okay?
Yep.
Right here? Is that all right? I was back. I was waiting.
It's not. Okay, there we go. Well, Tom and I were talking about this last night, and we finished the conversation with, I'd like to see that paper, for one, because I've read a lot of Lal's work, and I haven't seen that specific number. Right now, in terms of current emissions, land use and soils are not making up a 2 to 1 source compared to fossil fuels. Fossil fuels are more like 90% of current anthropogenic emissions. And what I'm thinking that we might be talking about is the carbon that has been lost from soils and vegetation changes over all time, since agriculture, possibly. And that's a lot more carbon, and a lot of that carbon was absorbed by the oceans. And so in terms of the last 100 to 150 years, my understanding is that emissions play a quite a bit larger role from fossil fuels. But I want to see the paper, and I know that Tom has read up on this quite a bit, so we'll stay tuned. All right.
Thank you. All right, I have one more over here. We have okay, lots of waiting, but we will we'll start back here.
I'll try to be quick. Is this working? I think so. Okay, is it working? Thank you. I'm with Nebraska Interfaith Power and Light, a faith-based organization that advocates and educates about the warming climate. Right now in Iowa, through the Iowa Interfaith Power and Light, there are groups of farmers who are gathering and beginning to work on the radical idea, at least for right now, that by using conservation tillage, rotational grazing, permaculture, extending crop rotations, a number of basic things, they can actually start really sequestering carbon. And they're actually proposing that the government pay them for doing it, as opposed to doing the agricultural payouts as they now exist for most of the kinds of arrangements that are made. Do you know about this, and what do you think about it? Thank you.
Yes, I know about it. Conservation tillage, or various forms of reduced tillage, has sometimes been regarded as a very effective way of getting or reducing the loss of soil carbon, and even increase the amount of soil carbon. But the scientific evidence is not really compelling about this. We know that there is a redistribution of soil carbon when you reduce the tillage, but the effect on the total soil carbon is probably not very different from a conventional tillage to reduced tillage. If you combine it with things like cover crops, making sure that the land is never bare, that has an impact. But the tillage itself has probably been overstated before. But there's one thing which is perhaps the most important difference between the conventional agriculture and the perennial polyculture. That's the root depth. Because the big difference between a natural ecosystem and an agricultural system is, of course, tillage. But it's also that we replaced very, very deep-rooted species with very shallow-rooted species that need to restart every year. So I would guess that conservation tillage in itself is not that effective.
Well, there are 5 practices that they're advocating, again, with the government begin to see these as essential for carbon sequestration and begin to pay them accordingly.
Yeah. If they combine, I'm all for it. But of course, reduced tillage is wonderful for reducing erosion, of course.
What do you think of the government paying for it? What do you think of the government paying for stored carbon?
I heard a question. I need some time to think because there is politics. I think is always very contextual. I mean, we have a very different mentality where I come from in Sweden, where we trust the government, we think that the government is doing good things for us. And that informs the whole society. And you can't take a Swedish political instrument and plant it somewhere else. In the same way, unfortunately, we take too many of the American political initiatives and try to plant them in Sweden. But I think that politics needs to be almost as contextual as biological or ecological solutions.